Hi, I am Indrajit and today we are going to discuss complex number. We are already familiar with real numbers and we know that in case of real numbers we cannot figure out square root of some negative quantity. For example, in case of real numbers we cannot calculate what is square root of -1. That is invalid for real numbers. And that is how complex number is different than real numbers. In case of complex number, we consider square root of -1 as I, which is known as iota. So in this way, if we have square root of -3, we can write this as root 3i. Similarly, square root of -4 will become root 4i, that is equal to 2i, and so on. In general, a complex number, say z, is denoted in this way: x plus iy, where this x is known as real part of z and this y is known as imaginary part of z. Remember that this x and y both must be real quantity. Okay? So here what we have got, that any complex number z is denoted by x plus iy, where x and y both are real quantities. So for example, suppose we have a z is 2 plus 3i. This must be a complex number. Okay? Here the real part of z, which is denoted by rez, real part of z is 2, and imaginary part of z, which is denoted by inz, is 3. Similarly, if we have some number -1 plus I, then in this case real part of z is -1 and imaginary part of z is +1. Okay? We have already said that we denote a complex number in the form x plus iy, where real part of z is x and imaginary part of z is y. So now, for any complex number z, we can plot that on a graph paper. That point which corresponds z should be x comma y. For example, if I have z is equal to 3 minus 2y, then here x is how much? 3. So just take 3 along x axis, and y is how much? -2. So go -2 units along y axis. So this point 3 comma -2 will denote z. That's okay. This point 3 comma -2 will denote z. Now you observe that we are plotting the real part of z along x axis. So this axis is known as real axis, and we are plotting imaginary part of z along y axis. So this axis is known as imaginary axis, and this plane where we plot a complex number is known as Argand plane. Now suppose a complex number z is x plus iy, and we are plotting that on the Argand plane. as a point x comma y. Now modulus of z, this is denoted by this sign, is nothing but the distance of z from origin. So here now you can easily understand that since this length is x and this length is y, what should be the distance of z from the origin? That must be, using Pythagorean, we can say that must be square root of x square plus y square. So that means for any complex number z, which is x plus iy, modulus of z is square root of x square plus y square. This is okay. For example, suppose we are talking about one z is three minus 4i. Then what should be modulus of z? Modulus of z should also to be square root of 3 square plus 4 square. This is root 25, that gives us 5. So in this case, modulus of z should be equal to 5. Okay. There is one more term which is related to complex number or position of a complex number, that is known as argument. Suppose we are plotting a complex number z which has coordinate x comma y. Now if I join this with the origin, then this line OZ will make an angle with this positive x-axis. That angle, theta say, is known as argument of z. I repeat it once again. If I join origin with the complex number z, then that line OZ will make an angle with the positive x-axis. That angle is known as argument of z. Now argument of z, which is denoted by this ARGZ, it is also known as amplitude. And sometimes denoted by AMP of z. That gives us this theta. Generally, the argument of z is calculated within minus pi to plus pi, and it is also known as principal argument of a complex number. So this is principal argument of z, which should lie between minus pi and plus pi into. Means what? That if a complex number is lying here in the first quadrant, then what will happen? This theta should vary between 0 and pi by 2. Okay, so in the first quadrant, argument of z should vary between 0 and pi by 2. If it's lying in the second quadrant, then what will happen? You can easily see that now this angle is obtuse angle, so it should lie between pi by 2 and pi. If it is lying in the third quadrant, then what will happen? We'll just calculate this angle now in a clockwise direction and we'll put a negative sign. So that's why in this quadrant, it should lie between minus pi by 2 to minus pi. Or we can write minus pi to minus pi. Similarly, if z is lying in the fourth quadrant, At that time, we will calculate it in a clockwise direction and the angle should be negative. We can say it is lying between minus pi by 2 and 0. This is okay. So suppose we have a complex number which is root 3 plus I. Now if I want to calculate modulus of z, that should be simply root 3 square plus 1 square. That gives a root 4. Should be. If we want to calculate its amplitude, now you just see that root 3 plus I should lie somewhere here, which has a coordinate root 3 comma 1. So how can I find out this angle? This angle is nothing but, if I take tan of this angle, that is nothing but 1 by root 3. Okay. So here tan theta should be 1 by root 3. If tan theta is 1 by root 3, then what should be theta? Theta should be pi by 6 or 30. So that's why we can that's how we can calculate what is the value of amplitude of z. Now let's see that if I have z is root 3 minus I, at that time what is happening? Modulus of z will remain same. That should be square root of 3 plus 1. But now in this case, z is in the fourth quadrant, root 3 comma minus 1. So if I take tan inverse of, or tan theta is now minus 1 by 3, 1 by root 3. So if you take tan inverse, that gives us minus pi by 6. So now here our argument of z will become minus pi by 6. Now just see that if I take some other case, suppose our z is minus root 3 plus I. Now where should it lie? It should lie in the second quadrant. That should be minus root 3 comma 1. So now this is the angle which we are talking about. In this case, if you take directly tan inverse, your tan theta is nothing but minus 1 by root 3, just like the previous case. So if I take tan inverse of minus 1 by root 3, we'll get that the answer is minus pi by 6. But whether, just see the figure, whether the argument is minus pi by 6. That is not true. It should be pi minus pi by 6. This should be the argument that is we are considering. So in this case, your theta is, your argument is pi minus theta. That is pi minus pi by 6, which gives us 5 pi by 6. Okay. Take another case. Where z is minus root 3 minus I. Now in this case, z is lying in the Which quadrant? In the third quadrant. Minus root 3, minus 1. So this should be the point minus root 3 minus 1. Now if I join Z with the origin, which angle will give us argument? This angle. So in this case, if you calculate tan theta, your tan theta should also be minus 1 by minus root 3, that is 1 by root 3. So theta should be tan inverse of 1 by root 3, that gives you pi by 6. But you see that the actual argument is, the principal argument is not pi by 6. In this case, what we are getting, that the actual argument is minus pi plus pi by 6. Okay. So in this case, argument should be equal to minus pi plus in this case also it should be plus, since this is directly coming minus pi. Minus pi plus tan inverse of 1 by 3. Okay. So now what we can conclude then, that when for any z x plus I y, when z is lying in the first quadrant, argument of z is tan inverse of y by x. When it is lying in the fourth quadrant, argument of z is tan inverse of y by x. When it is lying in the second quadrant, argument of z is pi plus tan inverse of y by x. And when it is lying in the third quadrant, then argument of z is minus pi plus tan inverse of y by x. So before finding the argument, we need to know it is lying in the which quadrant. Depending on that, the formula for argument will change.